So today I'm going to show you a couple of success stories on how we connect the dots with Alteryx. And these stories are not specific to one industry. We have found that these situations are very much in every single industry that we go into, whether it's retail, manufacturing, food distribution, medical, pharmacy benefit management. We see this trend often. So this is not unique to this industry. Alteryx is very much used widespread throughout many different industries. So what I want to do today is give you some success stories so you can see the power of using Alteryx. And these success stories are using very basic level 1 functionality. You're going to hear more about level 1, level 2, and level 3 tools within Alteryx as we get through our presentation. But all these two particular success stories were done with only level 1 capabilities. So the clinical area of a large pharmacy benefit manager roll out a program to monitor the wellness of patients based on how they take their medications, so that they can work with their doctor to improve their health. Just like a typical company, they put together a very heavy-duty industrial system that would take data from everywhere within the company, tumble it up, and get results out. It was so big and so heavy that it would only run once per quarter, and that resulted in poor data quality. So your typical analyst who would typically go out and perform data quality and get the analytics ready for the clinicians couldn't do it. So they had to solicit help from a pharmacist. So now you have two very high-level individuals looking at data and cleaning up data. As you can see, that was not sustainable for long. They came and asked me, is there any way to do this outside of putting a big project that it will take multiple years and multiple millions of dollars to put together? So as a matter of fact, we have been working with this tool Alteryx that gives us incredible flexibility when it comes to data crunching and analytics like this. So we went out and said, we're going to do a proof of concept. Let's look at it. So we built our workflow to use Alteryx in database processing. So we didn't have to take data out of the claims engine. We could run our workflow right then and there and use the power of that engine to do it. We asked the pharmacist, how would we identify the disease that you want to look at? So if you're looking at diabetics, heart patients, cancer patients, how can we identify who those people are based on their prescriptions that they take? And they came up with the National Drug Code. It's a unique identifier that basically designates those drugs to be used by a certain disease. So we build them a macro that they can input the National Drug Code so that our workflow will go out and gather all of the pertinent information about those claims and those drugs. And then we took a file from the medical provider to identify the patients that were filling those prescriptions. So now we had a data set that we could work with to identify who were the diabetics, who were the heart patients, who were the cancer patients. And then we took it a step further and we analyzed those populations to say, when you're talking to the doctors and the clinicians, what you want to do, you want to talk about the people who need help. You don't want to look for Tom, the good diabetic, who goes to the doctor on a regular basis, has a great diet and exercise, and takes his medications regularly and fills his prescriptions on time. What you want to look at Tom, the bad diabetic, who rarely goes to the doctor, has a poor diet, and doesn't fill his medications on a regular basis. And you see that every time Tom gets his medications, the dosage are increasing, or there's additional medications added to his prescription. those are the people that you want to look at. We use the workflows report capability to build a Tableau dashboard that very quickly and easily allowed the pharmacy benefit manager to sit with the doctors and clinicians and look at these populations to improve the health of their patients. That resulted into a very flexible platform. So think about it. Before, they could only do this every 3 months. And when you're thinking of the health of someone, 3 months is a long time, especially for someone who's sick. The health can decline very quickly in 3 months. Now they could react multiple times per day. They could look at these populations and get them to their doctors so they can help the patient's health. In addition to that flexibility, we built a QA step so the analysts and the pharmacists didn't longer have to sit there and churn through data to get to their end result. That was already built in with our workflow. So not only did we improve the health of people, we improved the value recapture for this company, where they didn't have to go out and spend $5 million on a new system and multiple years of effort putting it together. And they could eliminate the cost of their legacy system by $4.5 million. So $9.5 million value recapture is very powerful. When we presented that to the executives, they were so excited that they told me, we want you to go out to every single one of our business units and do the very same thing. So we enable a conservative organization to adopt Alteryx across their enterprise. And for those of you who are in healthcare, you know that most healthcare companies are very, very conservative, and tools like Alteryx are very slow to adopt. But in this case, this very use case enabled to have quick adoption of Alteryx through the organization. So then I'm going to take you to our next success story. So this one was another business unit that we went into with the pharmacy benefit manager. So the drug manufacturers had been asking the pharmacy benefit manager if they would be willing to provide analytics on the medications that they make and the utilizations by disease and by region. The PBM said, great, this is a good opportunity to make some money from our data. They started a project and found out very quickly that it was going to be, again, a multi-year, multi-million-dollar project. They talked about doing the identification at a claim level. If you've ever been on a de-identification project, are very complex, and yes, they are going to take their time because you're stripping all of the personal information at a claim level. So I said, let me do a proof of concept again and see what we come up with. I already knew that my previous success story, the previous use case, we already had the answers to the test, because I can go out and put in the national drug code and get the population back. All I had to do is aggregate it by region and strip all the personal information. So we added to our workflow, created a file, and you see here that our solution took 60 days. It didn't take 60 days for us to build a technical solution. That actually took maybe an afternoon. It took 60 days because we had to go around the company to make sure that all of the stakeholders were okay with us handing this data over to a third party to aggregate, to give to the drug manufacturers. I'm talking about your legal, your privacy, your compliance, your security. And once we passed all those tests, they handed us a check for $2.5 million. There's no greater feeling than walking into a chief financial officer's desk with a check for $2.5 million. We just made some money from data we already have. So what was his response? Great, I want more. So we went out and did this for 6 other drug manufacturers. And at the end of the year, they were making about $15 million in net profit from a workflow that we already built on the previous use case. That is the power of connecting the dots with Alteryx. When you have the right tool to do the job, it just makes it so much easier. It makes it easier to do and easier to explain. Next slide, please. So now we're going to take it a step further in our webinar here. We're going to show you how we connect the dots between your data analyst and your data scientist. Just imagine with very basic tools, we were able to improve people's health. We were able to make company money on data that they already had, build a new revenue stream for that company. Now imagine what we can do when you merge your data analyst, who's a subject matter expert in your business, with the techniques from your data scientist. You can build models that can predict, adapt, capture near real-time information. You can listen to the social networks and see how your product is doing in the marketplace. You can course correct, you can build upon it. So those are the true powers of Alteryx, and we're gonna show that to you next. So I'm gonna pass it to my colleague, Kirk King. He's gonna give you an overview of Designer Promote. He's gonna talk a little bit about the community of practice, which is very important when you're connecting the dots. So without further ado, here's Kirk.
All right, thanks, Tom. So I've been working with Alteryx for about 5 years. And can I get the next slide? And I've had tremendous success using, implementing, and coaching others in using Alteryx. Also in that time, I've had the opportunity to go to many of the Alteryx Inspire conventions, where I've listened and learned about so many of the others that have had the same tremendous and sometimes career-lifting success implementing and using Alteryx. But when I took a step back and looked at the tools Alteryx had to offer, I realized I was using just a small portion of these tools. So I set about to try to learn and implement some of these tools. I even took some online data science courses, and I quickly realized that I was going to take a long time, and it was really sending me down a path I didn't want my career to go. But in this process, I ended up grouping the tools into different levels. And the level 1 tools being the tools that I normally used and have seen most other analysts use. These are the same tools that were used in Tom's use case examples, and I usually see these tools displayed when seeing others demo Alteryx. They're a very powerful set of tools. But this got me excited because if I was having this much success with these tools, which was just a small portion of the tools offered, just imagine what can happen if we can learn to use all these tools. So then I combine these tools with all the products offered by Alteryx, Alteryx Server with Gallery and Scheduler, Connect and Promote. And I realized that as an enterprise solution, it needs to look a little bit different than just an analyst using the level 1 tools in Designer. So in today's demo, we're going to show how an analyst and data scientist can work together in a collaborative way with Alteryx. And we will then show Promote, what it is, how it is used, and how your IT department will use it to develop apps. But before we start, the next slide. Before we start, I want to talk a little bit about the community of practice and why it is so important using business enablement tools like Alteryx as a true enterprise solution. A community of practice is made up of 3 areas: domain, which are the areas of shared interest and key issues; the community, which are the relationships built through discussion, activities, and learning; and practice, which represents the body of knowledge, method, use cases, and tools developed. Next slide. For the domain, you can have your traditional groups like Alteryx, Tableau, data and analytics. However, I've even seen the community use the groups for remote workers or directors that wish to be unsiloed. The community then represents these domains coming together for group meetings, enterprise-wide collaboration, cross-domain knowledge shares, and can include guest speakers, both internal and external, and can help to communicate industry news. And while the user groups tend to get a lot of the focus in a community practice, I feel the most important part of the community is the practice, which is where your group knowledge can be shared such as best practice documents, shared code, training material, and a list of domain champions, which in the case of this demo is where I, the analyst, would be able to reach out to a data scientist, either through emails to the list of champions, or maybe their domain is set up with office hours so I can meet them in person and share my needs. So just one note, the difference between a community of practice and a center of excellence is the center of excellence usually has the authority to set policy, while a community of practice can point you to the policy. So for instance, a best practice document cannot supersede a policy such as data governance or compliance. But this also makes the community of practice much easier to establish and get approval for. And so with this, I'd like to turn it over to Gabby and let her show you what the data scientist can do with Alteryx.
Awesome. Thank you, Kirk. And just to mirror off what Kirk was saying, before I was even using Alteryx, I've been using the normal tools that a data scientist would use, such as R, Python, and then I was able to find Kirk in that community of practice, and he was able to show me all the cool products that Alteryx had to offer, and that's really how it got me interested in starting to be able to use these products. So today, I really want to show you flexibility that Alteryx offers for you by showing you different models, and each model is going to be dealing with different industries as well. So all these models can be applicable across industries and different types of data. But the first two models I'm going to show you are a clustering model and a classification model. And both of these models are using the native drag and drop tools within Alteryx. And then the third model I'm going to show you guys is if you are a data scientist and you are used to coding and you don't want to use a drag and drop tool, well, you can still code and write custom code inside of Alteryx. And then I'm also going to show you guys, once you have built a model, how to push that into one of Alteryx products, which is called Promote. And for those of you that don't know what Promote is, it is a way for you to manage and push your models into production in a very fast way. So I'm going to show you guys kind of a quick overview of that as well. But first things first, I'm going to start with the clustering model. And I just want to give a little bit of a background on clustering in case those of you listening don't know what it is. But basically what you're trying to do when you're clustering is finding if the observations group together in a predictable way. And so we cluster by measuring the distance or some other measure of similarity between different observations. So say you have a data set that included people's heights. Someone was 5'2", 5'4", 5'8", and 5'9". Between 5'2" and 5'4", that unit of difference is 2. So those two have a small difference, so they would be clustered together, whereas the 5'8" and the 5'9" would be clustered together because the difference between them are smaller than the difference between the 5'2" and the 5'8". So that's really what clustering is doing when we're measuring a distance. And that what k-means stands for, K stands for the optimal number of clusters that you're going to pick to segment your data into. And so how a k-means clustering algorithm works, let's say we set our k to 3. It's going to pick 3 random data points to start that as the center of your 3 cluster centers. So the 4th data point is going to come in. It's going to compute that distance between each cluster center. Whichever distance is smallest, it's then going to go ahead and push that data point into that cluster. And it's going to recompute the cluster centers using the mean as to why it's called k-means. So it's going to do this for every single data point in the data set until the data doesn't converge and all the points aren't moving and you have 3 distinct clusters. So when you are clustering, there are some choices you need to make within Alteryx and then also just when you are using clustering models in general. But these are the main choices you have to make in Alteryx and what I'm going to show you today. So I'm going to go over that really quick. Distance, you can choose what type of distance measure you're going to use. When you're using the k-means model inside of Alteryx, it uses the Euclidean distance. So that's what I'm going to show you today. You also have the choice if you need to standardize your data, which is very common when you're clustering. So for example, if you have a column that's measured in smaller units than another column, that column with very small units isn't going to play as much importance in the clustering algorithm. So you kind of want to get everything on an equal playing field in terms of the units. And so that's why we choose to standardize, so they all have an importance in that cluster model. And so you can choose to standardize by z-scores or by unit intervals. And for today, I'm going to show you guys unit interval. It puts the column between 0 and 1, so it's very easy to interpret. Your smaller values are going to be closer to 0, and your largest value could be 1. And then that optimal number of k you're going to pick, you can actually, you don't just do this randomly. You have different ways you can do this as a data scientist, but what Alteryx offers you is the Kolinsky-Harbaz index and the adjusted RAND index. And today I'm going to go off the Kolinsky-Harbaz index because it not only shows you how compact a cluster is within each other, but also how separated each clusters are from each other. So to give you a little bit of background on the data set I'm using today, it's historical sales data from 45 Walmart stores, and each store contains several departments. I was provided 3 tables: a features table, a sales table, and a store table. The features table contained information about the environment and the economic impact, such as the CPI or the fuel prices or the temperature outside. The sales table had information about sales per store and per department for that store. And then the store table had each store and its relative size. So before I show you guys the outcome of that clustering model, I'm actually going to go into Alteryx and go ahead and show you how easy it is to build a clustering model. And one thing to know is that, like in our community of practice, we discovered that having a template was one of our best practices. We have our version control on the left side, we have our headers at the top, and then we color code the different parts of our workflow. So anyone who's coming into this workflow or they need to make a change to it can easily find what's going on and where to look. So the first part of my workflow is really those level 1 tools that Kirk had talked about. So I'm not going to spend too much time here describing what I did, but basically I joined all those different tables I told you guys had together. And then I created one data point per each store that had some aggregation functions. So maybe I had the average temperature that purchases were being made at, or the average sales, the min sales, the max sales. So I did all of that here, and then I got rid of any duplicates. So I had, again, just one line per each store with all the information I needed. So the first thing you're going to do when you are building a clustering model, you're going to go up here to the predictive grouping section, and you're going to click on this K-Centroid's diagnostic tool and bring it into your workflow. So what this tool does is it helps you pick that optimal number of K. So you're going to pick all the fields that you want to cluster by here on the left side. You're going to choose how to standardize the fields, and you're going to pick that K-means clustering method. And then what you do is pick the number of clusters you want to look at the indexes for. So today I'm saying, okay, I want to look between 2 and 8 clusters to see what my optimal number of K is. And so you run that diagnostic, and I'm going to show you guys what you get out of that tool. So what you get is the index, the Kolinsky-Harbaz, and the adjusted RAND for each of those K clusters. So you can either look at the mean here in the table, or you can look at the chart down here. Like I said, I'm going off the Kolinsky-Harbaz, so you can see that the mean is the vertical, that horizontal line in these box plots. It looks like it's the highest around 3 or 4, so you want to go check. You see that 3 is the highest. And if you guys are familiar with elbow plots, this is kind of goes along with the same thing when you're picking that optimal number of K. After 3, you have diminishing returns, so you're going to go with 3 as your optimal number of clusters, and you're going to keep that in your mind when moving forward. So the next thing you're going to drag down is the K-Centroids analysis tool, and that's going to do your actual cluster analysis method instead of just finding your optimal number of K. So again, you choose the same fields you chose earlier, you standardize your fields. I picked the unit interval, and then I'm going to cluster on K-means, and here's where I pick that number 3 that I just got from that diagnostics tool. So I'm setting my number of clusters to 3. And now I'm going to show you guys how to interpret the output of this tool. So it gives you your 3 clusters and the size of each one. So that's saying that 11 data points got put into cluster 1, 13 got put into cluster 3. What you're given down here in this larger table is the centroids, or the middle of each cluster. And so the way you would interpret this is, let's look at the first column of size. You see cluster 1 had an average size of 0.87. So that means that cluster 1 was made up of a lot of your large stores. Cluster 3 had an average size of 0.24. So that means that that cluster had a lot of small stores in it. So you would go through every single one of the variables that you chose to cluster by and interpret it in this way. And so I've already done that for you guys today, so we can go ahead and look at the outcome. And so you can see that cluster 1 was made up of mainly large stores, and purchases were made when the economy was doing good and it brought in the most sales. Cluster 2 was made up of your medium-sized store, average sales were made, and cluster 3 was made up of your small stores, and they brought in the least sales. And so what does this information tell you? How can you use this as a business? Well, now you know that you have 3 distinct segments of your different types of stores, and you can target them in different ways. So say your cluster 3 is struggling with sales, they're your smaller stores, maybe you're going to do a different promotion than you would in those stores than your cluster 1 stores. You also know each data point that was assigned to each cluster. So if you want to take a deeper dive and see, which stores are making the most, which stores are specifically making the least, you can go ahead and do further data analysis there. But this really gives you an easy way to segment your customers and target them specifically. So again, this can be used across any industry. So that was the first model I had for you guys. The second model I have for you is a classification model, and this is the model where I'm also going to show you how to incorporate promote. So binary classification is the type of classification I'm going to show you today. And really what that means is that we have a labeled training set. So basically in the past, your company has collected data on something that they were trying to predict. So say in this instance, it's going to be a telemarketing company that's calling to see if a customer wants to opt in for a term deposit. So they've already done that in the past. They're going to record down whether the customer responded or not. And that's going to be why your training data set is labeled, because you actually know what happened in the past. And so binary just means a special case when there's only two classes you're trying to predict. And some things that are very common that use binary classification are credit card fraud. Is it fraud? Is it not? Medical diagnosis. Is this person going to get diabetes? Are they not? Spam detection. Your computer does that every day. Is this email spam? Is it not? A lot of different types of models can be used for binary classification. Some are decision trees, neural networks, logistic regressions, and support vector machines. And Alteryx supports all of these in their native tools as well as others. So the data set I'm going to show you today for this example is a bank telemarketing data set from the UCI Machine Learning Repository. It has information about the customers and the campaigns done by the bank towards a term deposit. So like I said, basically they had telemarketers calling their customers saying, do you want to opt into this term deposit or not? And then they wrote down whether they responded or not. And aside from just having that information, we also have some predictor variables. So we have age, marital status, education, job, and we also have some numerical and financial information. Has their credit ever defaulted? What was the average yearly balance? The number of days that passed after the client was last contacted, stuff like that. So the three different models I used were a decision tree, a logistic regression, and a forest tree model. They're some of the most popular and easier to interpret, so I thought they'd be good for this demo. And just a quick note on why I tried three different models. For those of you that aren't familiar with data science practice, you don't really know the underlying structure of your data or which model is going to perform best on your data. You might have an idea, but you don't know until you actually try out the model. And so if you were given data that you see on the left side and you didn't really know that underlying pattern of the data, if you used a logistic regression, it would create a linear boundary and it would classify everything above that green line as red and below that green line as blue. So you can see that all those red dots under that green line would be misclassified. But in contrast, if you were using a decision tree, every time a decision tree makes a branch, it kind of boxes in your data. So it's able to capture those more complex patterns and complex things in your data. And so if this were the case, a decision tree would be better because it's able to capture that, whereas a logistic regression would be too broad. But if the opposite can also be true. So if you have a problem that could be solved with a simple logistic regression, but you decide to use a decision tree, it's going to box up your data. And if you decide to use this to predict events in the future, you're probably going to vastly overfit your model and get some of those predictions wrong. So in this case, it'd be better to use a logistic regression because there is that linear relationship. You can draw that boundary and then you can make your classifications that way. So it's always very important to try different models since you don't know that underlying structure in your data. So now I'm going to go into Alteryx and show you what that looks like as well. Again, I did some simple cleaning of the data with those level 1 tools just to get it in the format I needed it. And then I split my data into a test and a train set. And so what I put into each of the models is my training set. You never want to use your full data set when you're training your model because you don't want your models to be overfit. So I'm just going to show you guys some of the options you have in case you do want to know what it looks like to use these tools. So all you have to do is choose the target variable, which is whether they responded or not. In our case, it was labeled Y. And then you're also going to choose all the variables that you want to make the prediction on that you think are going to play an important role. You can customize. So if you're not familiar with tuning your parameters, you don't even have to go down this route. But if you do want to customize your model, you have the choice to choose an algorithm, the hyperparameters. You can choose to use cross-validation, and you can also choose to output a tree plot or a prune plot. And you kind of have the exact same every single model that you're going to do is going to have the exact same options, but a little bit different just depending on the type of model that's being used. So for this, you can do logit, probit. You again have cross-validation, and then the plots are going to be a little bit different than a decision tree since it's not outputting a decision tree. So I've already ran these for you. So I want to show you how you would move forward after you've run a couple of different models and pick which model to move forward with. So as data scientists, you compute a lot of different things to validate your models. Some of the most common are your accuracy, your F1 score, your precision, and recall. And so you can look at all these things and compare across your models to see which one performed best. So you can see in this case, the decision tree had a 90% accuracy, which is great, very high precision and recall. It also gives you the misclassification, so you get that confusion matrix, and you also, like I said, can output the tree. So you can go ahead and look at what variables played a really important part in making that prediction. And I also want to show you what a logistic regression output looks like, just so you guys can see that the outputs do differ a little bit depending per model. Again, you're going to get that F1 score, the accuracy, the precision, and recall. And in this case, you're also going to get the optimal probability cutoff. You can see here that this model did not perform as well as the decision tree. It was only 82% in accuracy. You do get your conditional density plots in this one. That's something you didn't get in your decision tree. And then another thing you get is an ROC chart and a precision versus recall chart. So again, you do get different things per model, but they are very similar. And so after I evaluated all my 3 models, I decided to move forward with my decision tree model. It had the best accuracy, it had the best precision and recall, all those things I were looking for, they all matched up. And so my next question to myself is, okay, I have this great model. It can be used to predict whether we should call this person or not. I need to get this to my analysts or to my frontline employees. I need to distribute this across my company so people can actually use it. And so the first way we thought of that people could do this was by creating a macro. So say you don't have promote yet, you can turn this model into a macro, and all you have to do is train your data set, give it to the model, and then create this macro input and output. So people are just going to have to give you a file or give you a text input, and you're going to get those prediction scores on an output. And all you have to do is either upload that macro to a shared drive or upload it to your gallery, and anyone can go ahead and pull it down and run it in their workflow. And so if you're not a data scientist, you don't know how to tune all those parameters, you don't know how to train your model, great. You don't even need to think about that. You now just have it as a macro, and you know if you put data in, you're going to get that prediction out. And what the prediction out looks like is the probability scores, probability 0 being you shouldn't call them, probability 1 being you should call them. And I'm just going to show you real quick. Me and Kirk do have a shared folder that we use here for just that. It's in Alteryx workflows. So I upload all the things I do here so Kirk can access them. And then also we do have our gallery set up. So at any point in time, for everyone in the organization to access it, or whoever has access to gallery, this is a great offering, and it's a really easy way to manage and organize all of the workflows that you guys have saved across your organization. But the really cool part I wanted to get to today is promote. And so like I mentioned before, promote is where you can push your models into production and manage them. This is the landing stage of promote. So you, as being a data scientist and not a manager, I can push my model from dev to staging, but I can't push it from staging to production. Only a manager would be able to do this. But it's an easy way to see where all your models are at a certain point in time. You can then click into your model, and this is the really cool thing about promote. If you name your model the same thing every time, it's going to automatically do version control for you. So you can see I have all these different versions. I have all the different build logs. So at any point, I can go and redeploy an older version if I wanted to. I have the model name here, the API endpoint, the number of replicas, and the active version that's running right now. You can execute your model in here to make sure that it's working. So you can put in some test data and spit it out just to make sure that it's working. This is the best part, I think, about promote. So a lot of times as a data scientist, when you build your model in Python or in R, and then you're trying to push it into production, it takes a lot of time for the IT team to rewrite that code into the language that they need. But what you do when you push your model into promote, it's going to be hosted on here now. And so you have that API connection, they can hit the API, and they're able to run the data through the model and get that output back. So all your IT team needs is this snippet of code. So if their front-end application is in Ruby, Java, PHP, Salesforce, whatever it's in, these are the options Alteryx has to offer right now. All you have to do is send them this snippet of code. So it kind of takes away the whole pain of having to refactor that code. Like I mentioned before, you have every version on here for version history, so I can redeploy one at any time. You have the log, so if something didn't build successfully, my last build did build successfully, but if it didn't, I could go through the logs and see where it messed up. You have analytics, so anytime the model is hit, you can see how many requests have been made, the response codes, whether it was a failure or success, and you can also see the mean latency in milliseconds, so you can see how fast it took for your model to respond, which usually is around, when I've done this before, 5 to 9 milliseconds, so it responds very fast. You have your history, so you can see what the input and the output was. This was when I did a test run. You can see the input and you can also see what the prediction output was. And you have some filters on the left side to filter through all that data. And then lastly, you have your advanced section, which you can increase your number of replicas, restart, redeploy, or delete your model at any time. So Promote is a really cool way to manage your models, very fast, very efficient, and you can do it deploying straight from an Alteryx workflow, or also you can push from your custom code. So if you're in a text editor, Alteryx has some commands that lets you push your models straight from your text editor into Promote, so you don't even have to touch the designer if you don't want to. So that's what I have for you guys on my classification model. And lastly, I'm gonna move to my last model, which is topic modeling. And the reason I wanted to show this again was the flexibility of using a normal Alteryx drag and drop tool and writing your own custom code. So Alteryx currently doesn't support a tool with topic modeling, so I thought that this would be a great example. When I gave this presentation, it was in Minneapolis, so I made it relevant and I collected tweets about the Austin airport and the Minneapolis airport. So again, just a background on what topic modeling is if you guys don't know. Every morning, I'm sure you guys read some articles or you read a newspaper, and I'm sure you could go tell your family members or your wife or your husband, whoever, like, oh, I just read an article about this. Every article or document has a topic. So what topic modeling does is it says that each document can be described by a distribution of topics, and each topic can be described by a distribution of words. And so a simple explanation of this, LDA is a really popular type of topic modeling. So you can read those 3 sentences I wrote below, A, B, and C. If I ran LDA on these 3 sentences, pretending that each sentence was a document, it would say that sentence A was 100% about topic 1, sentence B was 100% about topic 2, and sentence C was 50% about topic 1 and 50% about topic 2. It will also discover that topic 1 was about soccer ball play in World Cup, and that topic 2 was about sauce, spaghetti, meatballs, and pasta. So LDA isn't going to immediately tell you, oh, this topic is soccer, but it will give you that distribution of words, which you then have to go and interpret as a topic. Oh, sorry, I did that too fast. And then let me just give you a background of the data set that I was using as well. So I was pulling data from Twitter. I used a Python, which was a Python package to pull live data. I was using the developer version to connect to the Twitter API, the free one, so I only was able to have a 100 pull limit per search term. But I decided to use the search term MSPA Airport and Austin Airport because those are the official Twitter handles. So I knew if people wanted to talk about things going on in the airport, that they would actually tag the official Twitter handles. And then I used a regex function to pull out the body of the tweet and place all the Austin ones into an Austin data frame and the MSP ones into an MSP data frame. And the reason I had to use a regex function was because when you hit the Twitter API, it gives you a bunch of information about a tweet, not just the body. So I only wanted the actual text of the tweet. So now I'm going to show you in Alteryx how you can write your custom code and be a little flexible that way. So again, I have my template, and I'm going to go up here to the developer tools section, and you have a lot of different options here, but what we're focusing on today is the Python and the R tool. I'm more comfortable in Python, so I decided to drag down a Python tool, but you can also write an R script. And so what the Python tool does is it opens up a Jupyter notebook for you inside of Alteryx locally. And if it doesn't have the packages or the libraries that you need installed already, you just simply have to run Alteryx install package, and it downloads that package for your use. So I just imported the libraries I needed. I set up my access to Twitter so I could grab those tweets from the API. And again, I created that function so I could just pull out the body of the tweet instead of getting all that information back. So here is where I am making the call to the function. I'm saying I want to search Austin Airport, MSP Airport. I want to grab the whole tweet. So I call the function here, and then I'm going to output that data to a data frame. So it's important to note when you're bringing data into a Jupyter notebook or out of the Jupyter Notebook, you can only pass through data frames. So that's why I put it into a data frame instead of a list. But you can see here all my Austin ones that mention the Austin airport, and then all my MSP ones here that mention the Minneapolis airport. Then I brought these data frames out into Alteryx to show you that you can bring it out and you can use their native tools to do some more processing on the data. So since I used the free developer version to access the Twitter API, I did get some repeat tweets as it gives me some historical tweets. And so I used the unique tool to just get rid of those duplicates. And then I brought it back into my Jupyter Notebook again to actually begin my topic modeling. And so again, I import it, I import the libraries I need, and then I do some data cleansing. So I remove usernames. I don't need that. That's not important in my topic modeling. I clean and tokenize the text. So basically, I'm removing any stop words, any punctuation. I'm normalizing all the words. So kind of removing those endings from the words and just getting the root of the word. And then I'm preparing my document term matrix, and I'm telling LDA, I want you to find 3 topics and give me back 4 words within each topic. And I want you to do this for the Austin airport data frame and for the MSP airport data frame. So what I end up with is 2 data frames with 3 topics and 4 words per each topic. And I ran this a lot before I gave my presentation in Minneapolis, and I actually got some pretty cool results that I want to show y'all. So when I ran it on April 16th, Trump and Air Force One was at the airport, so you could see that people were talking about that. There was an MSP power outage. People were talking about that. I think the coolest insight I found, though, was at Austin, there's a robotic coffee machine that gives you coffee, and the company is called Brigo. And so I'm sure Brigo did this as branding. They wanted people to be aware of their company. There's so many people coming through an airport a day. So if they wanted to see if people were actually talking about their product and creating that buzz, they could create a model like this to see if it was actually being brought up by people at the airport or who were tweeting to the airport. So again, this can span across any industry, across any company. If you want to see what people are saying about your brand, this is a great way to do it, all inside Alteryx using custom code. So that's all I have for you guys today. Hopefully I was able to show you the flexibility within Alteryx and all the different choices that you have to make. Thank you for listening, and we are open to any questions.
All right, so you guys can go ahead and type any questions in the Q&A. It looks like we have a couple questions right now. So how much, oh, and we also do have a Alteryx representative here to answer any Alteryx specific questions. So the first question is, how much does Promote platform cost?
So I think that's addressed to me then. This is Dan with Alteryx. The answer to that, I can't give you a real specific answer because it really depends on the situation. I can tell you that it is in line with what you would expect based on the other Alteryx products that you might own. So my recommendation on that is to work with your Alteryx rep and first of all, see if it would be applicable for your organization, and then they can discuss different pricing options.
All right, next question. Can you run multiple MS Word or text documents through something like topic modeling?
Yes, you could. You would just have to turn it each document into a corpus. But yes, that is, you can do that.
All right. How many users do you need for platform to be economic?
Well, which platform? The Promote or Server or the Designer?
I believe it would be for Promote.
Huh. That depends on the business need. In the case of one, go ahead, Dan.
I can help with that one. So if we're talking about the Designer product and the Server, it really varies by organization. I mean, we've seen people with 5 designers own Server and Promote. We've seen companies, go towards Server with 20 plus users. So it really depends on the organization. For Promote specifically, typically it's the need is in the data science community inside your organization. So it could be justified just based on a handful or a small number of users and how you would deploy the product. So there isn't really a set number, but again, we'd love to explore that with you and kind of talk through it with your team and see what might make sense. So between the SenseCorp team and your Alteryx rep, we'd be happy to have those conversations with you.
Is there any tool or library available for deep learning in convolutional neural networks?
Yes, they actually have neural networks as a drag and drop tool inside of the designer.
All right, there's a question about will this recording be available for later review? And I just wanted to make sure that everyone knows that we'll be sending this out afterwards, so you will be able to review that content. Can Alteryx handle images as data?
I have not tried that yet. That's a great question. I'm not sure about that.
You have the ability to use the blob data types, so you can pull those images in. I'm not sure, depending on what you want to do with those images.
Yeah, I haven't tried to do image recognition, but we can find out if that's possible.
What do I gain from incorporating server instead of just using the designer?
So I can answer that a little bit. The server gives you one as a platform for doing applications, which Alteryx actually supports. So in the instance of this demo, if I'd gotten that macro from Gabby and deployed it to an application, people without designer could log into the server and run that application. They also do version control and scheduling with that server.
Yeah,
Well,
and I can add to that answer as well. So I try to simplify things as much as possible. So I like to think of the reasons customers go to server by thinking of the 4 S's. So the 4 S's are scalability, the ability to process more data more quickly, scheduling, so the ability to schedule these processes to run whenever you want them to, sharing. So Kirk already mentioned the ability to produce applications with the designer. So the idea behind that is you could have your designers building workflows and then convert them into applications which are web-facing that anybody in your whole organization could consume and run those apps, and they don't need an Alteryx license. All you need is one server license and you could scale it across the whole org. And then the fourth S is security or governance. So to keep our IT friends happy, it's really the best way to govern what's going on in Alteryx is to be a server.
And what it really becomes, it becomes your ability to roll this out to your enterprise with some very nice controls.
All right, so that looks like that's all the questions that we have. So thank you all for attending our webinar. You will receive a follow-up email with the webinar recording and other links to explore. I will make sure that you have access to any slides that you asked about, and if you have any additional questions or are interested in having a follow-up conversation, feel free to email me directly at info@sensecorp.com. Again, thank you for joining us and enjoy the rest of your day.